This is Mr. Tovert's class. This is lesson 5. It's going to be about the gas laws. Let's review a couple basic terminology hits here. Let's just review a couple of these terminologies before we get this started. Properties and behavior of gases. Have you ever seen a hot air balloon? Hopefully you have. Had opened up a bottle of soda and it sprayed all over, baked or eaten something nice and fluffy. All of these are examples of gases hard at work. So you can predict the behavior of gases based on the following properties. You can predict them based on pressure, volume, amount in moles, and temperature. So let's talk about each one. Let's start with pressure. Pressure is defined as the force the gas exerts on a given area of the container in which it is contained. The SI unit for it is called the Pascal. Next is volume. Volume is a three-dimensional space inside a container holding the gas. The SI unit for volume, of course, is cubic meters, or the liter, or you guys also know it as the milliliter. Amounts in moles. A mole is an amount of a substance. It's a little bit tricky. The SI unit for an amount of the substance is called a mole. Since we can't count molecules, we have to convert measured mass in kilograms to the numbers of moles and molecular formula weight. We'll talk about that a whole lot later. We'll be talking about what's called Avogadro's constant, which is 6.022 times 10 to the 23rd particles. Temperature. Temperature, of course, is a measurement of heat and how fast these particles are moving. Gases at room temperature have lower boiling points than at in the state where they're liquid or solid at the same temperature. Remember, not all substances freeze or melt or evaporate at the same temperature. How are they related? Some relationships are hard to see, some we have to break it down. So let's break it down. Boyle's law. This was named after Charles Boyle in the 1600s. Boyle determined that for the same amount of gas, if it was constant pressure, the result would be an inverse relationship. When one goes up, the other goes down. So what does this look like? Here's a great example of that. I'll talk about this more in class. I'll slow it down there. Charles's law in the 19th century. He said there's a direct relationship between temperature and pressure, or temperature and volume. As the temperature goes up, the gas wants to take up more space. Let's look at what that looks like. There it is, a direct relationship. All right. Now that's the end of that lesson, and we are ready to move on to lesson 6.